Okay, so let's consider this problem. Consider LC circuit consisting of an AC generator, inductor capacitance L, and a capacitor capacitance C. So this is a AC generator. I'm going to basically plug it into inductor. This inductor will have inductance L, and I'll plug it next to a capacitor, and I'll complete the series up like that. Okay, capacitance C. Okay, so first thing I figure out what the resonant frequency. If I swap the inductor with an inductor 2 times the inductance, how does the resonant frequency change? Well, if I swap out the inductor with capacitance 2C. All right, so there are several ways of doing this. All right, the easiest way perhaps is to look up basically what the definition of resonant frequency is. Here's a hint. This will look like omega 0 is equal to 1 over square root of LC. Okay, we're not going to do that. We're actually going to sit down and actually work through it, and then you'll see basically how this thing works. All right, so if you use this formula right here, you can get out pretty much everything you need to do. All right, but what we are going to do instead is we're actually going to go through all the entire process. So let's go ahead and do this. All right, so let's use Kirchhoff's law first. Start here. Basically, you get V0. All right, put the I coming this way. Okay, V0 cosine omega t minus L di dt. Okay, minus Q over C, and then come back, that's 0 again. All right, so now the key is that basically Q is equal to di dq. Okay, sorry, I is equal to dq dt. Okay, right, and we're gonna plug this piece in here. So that. So then what you end up getting, so I'm going to divide by L first. L. Okay, so I'm going to plug into that, and I'm going to get basically something like this: d squared q dt squared. Okay, plus now I'm going to shift. I'm going to put a minus sign on everything, so change to the plus. There's a minus, move to this side. Plus basically 1 over LC q is equal to V0 over L cosine omega t. Okay, right, so that's roughly the statement first. All right, and then what you do is you complexify this thing. So complexify, and what this does is that you turn cosine omega t to exponent I omega t. All right, so it's going to be equal to V0 over L e exponent I omega t. And now we have the guess. So the guess is Q is equal to some A exponent I omega t. Right? Okay. So once we have that, we're going to plug this into here. Right? And what we will get is something that looks pretty simple. This will be basically d squared dt squared, okay, of A exponent I omega t plus 1 over LC A exponent I omega t, and then the final thing is equal to V0 over L exponent I omega t. Okay, this thing will hit it twice. We'll pull out two factors of I omega, so it'll be I omega squared, which would be minus omega squared. So minus omega squared A exponent I omega t plus 1 over LC A exponent I omega t is equal to V0 over L exponent I omega t. Okay, so miracles happens. This all kills each other. And now I can solve for A, right? So A is going to be equal to V0 over L divided by, now see, so this is going to be 1 over LC minus omega squared, right? So now the resonant frequency, whoops, I'll show you that one again. Now the resonant frequency will automatically pop out. Why is that? You find when A, script A is largest, and that is basically when omega squared is equal to LC. So basically A blows up when omega squared is equal to 1 over LC. And so this is the resonant frequency, which implies omega equals omega 0 is equal to 1 over LC square root of that. All right, so that's the resonant frequency. Okay, so for our resonant frequency, I'm going to draw a line right here so I can just plug this in. So what's the resonant frequency? Omega resonant is equal to 1 over LC, take the square root of that. Okay. Okay, so that's the first thing. If I swap out inductor with an inductor of 2 times inductor, how does the resonance frequency change? So if I swap out the inductor with something that's twice, so I make it twice, so that means that the new resonant frequency, I'll call it prime, is equal to 1 over square root of 2, right? Because I put a 2 there, of the old resonant frequency, right? So it basically gets reduced by 1/2. Now, if I swap out the capacitor 2 times the capacitor, same thing happens, right? All right, so basically omega resonant double prime is equal to 1 over square root of 2 omega resonant, right? Okay, that was very simple. You could have gotten it from here if you knew what the form of resonant frequency, but if you don't, go through all this and then you could get it that way as well. All right, and that's it.